Okay, everybody, what we're going to work on today is we're going to take some notes on a twist of systems of equations. And what we're going to notice here is that we have a system, but almost in disguise. What we have here is a scenario where we can make common bases. So we say to ourselves, what's the common base between 2 and 8? And I'm hoping at this point in the year you can say, hey, they have a common base of 2. So what I'm going to do here is write this guy as we got the common base of 2, so I can leave him alone. But 8 equals 2 to the third power. Down here we have a different equation, and we'd say, what would our common base be here? Well, the common base here is actually going to be 4. We have 4 to the 2x plus y equals, and how do you create 1 from any base? You set it to the 0 power. So now, let's just take a look at the top equation. Once the bases are the same, all we have to do is work with the exponents. So this whole top part becomes x plus 2y equals 3. Now let's look at the bottom equation. Once the common base is 4, all we have to do is work with the exponents. So right underneath this guy, I'm going to put 2x plus y equals 0. Now, we did solving equations or systems of equations earlier in the year, and what we learned then was we need to eliminate one of our variables. So I'm going to take the top guy and multiply it by -2. So that the top becomes -2x minus 4y, 2x plus y equals 0. And now we're going to add these guys together. Now when we add these guys together, these are going to cancel, and I end up with -3y equals -6. I'm going to divide both sides by -3, so now I discover that y equals 2. So I've got one of the pieces to my system, but I need to figure out what the x will be. So I'm going to go back up to one of the original equations and plug 2 in. You can either go here or up into the original, it doesn't really matter. I'm just going to take the top equation. So I'm going to do x plus 2 times, we know now that y is 2, equals 3. X plus 4 equals 3. Subtract the 1 over. I end up with x equals -1. And if you notice, it should work here as well. 2 times -1 is -2. -2 plus 2 makes 0. So this is the answer to the system of equations. So that's it. That's all there is to it to do one of those. Now, next I'm going to move on to quadratics in disguise. And let's see what that's all about. I'm going to move this up a little bit. Let's look at this first equation. Log x, log base 3x squared plus log base 3x minus 12. What we're going to do in this scenario is you're going to take whatever is in the parentheses being squared. We're going to make that our x, or I'm sorry, our y. I'm going to make a let statement. Let y equals log base 3x. And then anywhere in this equation here that I see a log base 3x, I'm going to substitute in a y. So right here I have y squared plus y minus 12 equals 0. That's a really simple quadratic that we can factor. It factors into y plus 4, y minus 3 equals 0. Notice I have the equals 0. Some of you have a really bad habit of forgetting to put those. That's important. So when we solve this, we end up with y equals -4, y equals +3. Now, this question wasn't about y's. It used to be about logs. So right here at this step, we're going to substitute what y is worth back into the equation. So right here, I'm going to write log base 3x equals -4. Log base 3x equals 3. Now it's a log question, and we got to use Ben to fix it. So we write 3 to the -4 equals x. Well, 3 to the 4th power is 81, and a negative exponent means flip it. So this is 1 over 81 equals x. That is one of our answers. This one is going to be 3 to the third equals x. So that's 27 equals x. Now keep in mind, you do have to check back into the original. Remember, you can't have a 0 or negative in this location, which neither one of these do that. So I'm going to circle both of them. And that's all there is to it. So if you notice, it was a quadratic in disguise. Now we're going to see that happen again with these. These are a little different, but the same idea. Whatever's in the parenthesis being squared is going to be our y in our let statement. So I'm going to write let y equal 5 to the x. And then everywhere I see 5 to the x in this equation, I'm going to substitute in a y. So this becomes y squared minus 3y plus 2 equals 0. Then all we have to do is factor this. I have y minus 2, y minus 1 equals 0, which gives me y equals 2, y equals 1. Now at this stage, we bring back in what y is equal to. So I'm going to put 5 to the x equals 2, 5 to the x equals 1. So now, once again, we're going to use logs to solve this. There's an x in the exponent. Remember, we're going to log it. So this becomes x log 5 equals log 2. This one becomes x log 5 equals log 1. Now we're trying to get x alone, so I'm going to divide by log 5. And this is where our calculators come in. All right, we're going to type in log 2, close the parenthesis, divided by log 5. And I want to round the answer to the nearest hundredth, so it's going to be x equals 0.43. Now I'm going to do the same deal here. Divide both sides by log 5. Now, if some of you remember, log 1 actually equals 0. So this answer is going to come out to be 0. But if you didn't remember that, you can get it right in your calculator. You just do log 1 divided by log 5. And there's the 0. Now, this isn't a log equation, so we don't have to worry about checking it. But you can always do that if you'd want to. It'll work. Now, this next one's a little different. A little more complicated. If you notice, in these last couple, this and this were the same. Same thing happens here. 5 to the x, 5 to the x. In this one, these are different. And this is where we bring our common bases back in. Is there a common base between these guys? So anytime they're different, you're thinking common bases. Yes, they have a common base of 2. So what I'm going to do first here is change this to 2 squared x plus 7 to the 2x plus 12 equals 0. Well, this now becomes 2 to the 2x and in other words, I can write it like this. So now the pieces in the parentheses are the same, and that's going to be our y. So I'm going to write, I'll put it up here, let y equals 2 to the x. So I get y squared plus 7y plus 12 equals 0. This factors. And we end up with y equals negative 4, y equals negative 3. But don't forget, you got to bring in your y equals. So I get 2 to the x equals negative 4, 2 to the x equals negative 3. Now if there's an x in the exponent, we're going to go with common basis. So we've got x log 2 equals log negative 4. Now let's see what happens with this one. So I go to my calculator. I type in, I can't find it, log negative 4 divided by log 2. It says normal answers, error, normal answers. That's because you can't have a negative here. So as soon as you have y equals a negative in these equations, it's going to be no good. We're going to have to reject it. Oh, wait, we have the same thing here. So my intuition is telling me that's going to give us no solution. So let's see if that happens. x log 2 equals log negative 3. If you divide by log 2, let's see what happens. So quit out of that. Log negative 3, oop, I didn't close the parenthesis, divided by log 2. Once again, we got the error message. So this question has, whoops, no solution. All right, so now for homework, you have a couple questions to do on the back, which model. So use the front of your worksheet to help you out with the back, but it's basically the same thing. And if you get an error message in your calculator, it means you can reject an answer. All right, good luck.